Section 3.2 is on acceleration, and we are going to speed through this section. Okay, so acceleration, you know if you've taken physics or if you're taking it, acceleration is the change in velocity over change in time. The rate of change of velocity with respect to time. A rate of change of velocity. You know what that sounds a lot like? It sounds like that you would take the velocity, take the derivative of the velocity, and you'll have acceleration. But wait a minute, remember what we said about velocity last day? We said velocity is the derivative of the position function. So if velocity is the derivative of the position function and acceleration is the derivative of velocity, does it not follow that acceleration is the second derivative of the position function? And I think we already mentioned this. I gave it away before when we talked about higher order derivatives. So a of t, acceleration, is equal to v prime of t, just like I wrote above. It's equal to the derivative of velocity, and acceleration is also equal to the double prime, the second derivative of the position function. So with that in mind, let's do a question. One whole question today, is it? Wow. The position function of a person on a bicycle pedaling down a steep hill with steadily increasing effort in pedaling, so they're starting to pedal a little harder and harder and harder and harder, and they're doing that steadily. This is the function right here, where s is measured in meters and t in seconds. Find the velocity and acceleration as a function of time. Okay, let's get the function for velocity as a function of time. In order to do that, we're going to take s, the position function, we're going to take the derivative of s, right? So let's do that now. We're going to do the power rule 3 times here. So the 3 comes down and you multiply. Just to make it a little more obvious what we're doing, I'm just going to write 3 over 6. I know you're probably saying, come on man, you could simplify that. I know, I will. And the 3 of course drops to a 2. Plus, 2 comes down and multiply, so you get 2 over 2, t to the 1, and then the derivative of t is just 1. Okay, let's simplify. 3 over 6 is the same as 1 over 2 t squared. 2 over 2 is just 1, so you don't have to put it, you just have t, and then you have that plus 1. So this is your velocity function right here. Let's get our acceleration function now. Acceleration is the same as the derivative of velocity. If you want, you can also say it's the second derivative of position. So we're taking this circled one here, and we're taking the derivative. So 2 comes down, so we have 2 over 2 t to the 1, that drops to 1. Derivative of t is just 1. Derivative of 1 is 0, so don't do anything there. If we simplify that, I think you just get t, don't you? 2 over 2 is 1, so you get 1t. Oh, sorry, we get t plus 1. My gosh. I don't know what happened there to my brain. So t plus 1 would be your answer here. So find the acceleration at 2 seconds. Well, what we want to find then is what's a2, which is the same as, you certainly don't need to write this, the same as v prime of 2, or the same as s double prime of 2, which means it's equal to 2 plus 1. Just plug 2 into right there, you get 3. 3 what? Well, I think we're talking about meters and seconds here, aren't we? Meters, seconds, yes. So this would be meters per second squared. Okay, last thing here. A negative acceleration. So in other words, if a is less than 0, which is the same as saying v prime is less than 0, which is the same as saying s double prime is less than 0. What does that mean? Well, if acceleration is less than 0, if you have a negative acceleration, what does that mean about velocity? It means the velocity is decreasing, right? You're going slower and slower and slower and slower. Alternatively, if you have a positive acceleration, then velocity is getting faster and faster and faster. Velocity is increasing. So to finish off here, let's just draw a very simple little graph. We're not going to do position and time. We will do time like we often do in these graphs. So this is time along here. But we're going to put velocity along the y-axis here. And let's just draw some graph. Let's just say it goes something like this. So if we pick a point right here. So this point right here has a certain velocity, right? At t, whatever this point is right here, it has a velocity of whatever that point is there. But say we wanted to know what the acceleration is at that point. Well, then what we would do, surprise, surprise, we would find the slope of the tangent line. So what I'm going to say, I'm going to say acceleration equals slope of tangent line on the velocity function. So in this case, if you take a look at this tangent line right here, what would you say about acceleration? Positive or negative? Positive, right? It's increasing. This is a positive slope here. So acceleration is positive here. The speed is getting faster and faster and faster, and you can see the speed's getting faster and faster and faster. It's going up. Okay, what if we looked at this point right here? Well, if I was to draw the tangent line there, it would look something like this. So at this spot, it has negative acceleration. In other words, it is slowing down. And again, that should be very obvious to you. The velocity is getting less and less and less and less. It's definitely slowing down. What if we looked at this point right here? Well, if we looked at this point, the tangent line would look something like this. What's the slope of that? 0. So in this case, acceleration is 0. So does that mean it's not moving? No, it doesn't mean that. It means at that point right there, the velocity isn't changing. It's staying exactly the same. It might just be for a second or part of a second, but for that little bit right there, the velocity is staying constant. It's definitely moving. Look at the velocity is not down at 0. There is a velocity, but it's not changing. But then as we go down here, velocity is getting slower and slower and slower, which means negative acceleration. And as we go up and up and up and up, we're speeding up, so we have positive acceleration. The key point here again is what we're finding when we're getting derivatives is slope of tangent lines. This is why I want to include it. And with that, we're finished. You might say, where's the back side of the page? There is none. This is unbelievable. Enjoy all the extra time you have. Go do some exercise or learn an instrument, master a new language, whatever it is that you're passionate about. You've got extra time to do it now.